We will now discuss the meaning of solubility. Now, if I start dissolving salt in a certain amount of water, can you dissolve any amount of salt in a given quantity of water? Well, no. A time will come when no more salt will dissolve in that solution. So there is a limit to how much solid can be dissolved in a liquid. Now, the term solubility is used to explain how much of a solid, or what is the maximum amount of solid that can be dissolved in a solution. The solubility of a solute is the maximum quantity of the solute that can be dissolved in a certain amount of solvent at a specified temperature. Why? Because if you increase or decrease the temperature, the amount of solute that can be dissolved in a solvent will change. Why? You see, the amount of solvent, the amount of solute that can be dissolved in a solvent depends on the space between molecules of the solvent. You see, a solution is a homogeneous mixture of the solute and the solution. That means the molecules of the solute are going to be in between the molecules of the solute. If there is more space between molecules, more solute molecules can find place to go and park themselves. Is that right? Now, when you increase the temperature, the speed of molecules will increase. The space between them will increase. That means more solute can dissolve at higher temperature. Conversely, if you decrease the temperature, what will happen? The space between molecules will decrease. That means there will be less space available for the solute molecules to park themselves. The ability to dissolve will be less. So the ability of a solute to dissolve itself in a solvent depends on the temperature. So look at the definition of solubility of a solute. Solubility of a solute is the maximum quantity of a solute that can dissolve in a given amount of solvent at a specified temperature. Solubility of a substance depends on temperature. If sugar is added to cold tea, after some time sugar will accumulate at the bottom of the cup because no more sugar will dissolve. But if you now heat it, more sugar will dissolve. So if you heat the cup of tea, more sugar will now dissolve. Try it if you don't believe me. Now, usually more solute dissolve in a solvent when the temperature is increased. Well, this happens only for a solid. If the solute is a gas, that is going to be slightly different. We will talk about that as we move on. A solution that contains the maximum amount of solute dissolved at a given temperature is called a saturated solution. So a saturated solution contains the maximum amount of solute that can dissolve at that particular temperature. It is saturated. Now, we had talked about saturated atmosphere, when the atmosphere is saturated with water vapor. In the same way, a solution is saturated when it contains the maximum amount of solute that can be dissolved in that solution at that temperature. A solution that is saturated at a given temperature will become unsaturated when the temperature is increased, because at a higher temperature more solute can dissolve. Now, the solubility of potassium nitrate varies with temperature like this. That means as the temperature increases, the ability of potassium nitrate to dissolve will increase. Now, at 20 degrees Celsius, if 10 gram of solute is dissolved in 100 gram of water, at 100 degrees Celsius, 100 gram of the solute will dissolve in there. So as the temperature increases, the ability of a solute to dissolve will also increase. While solubility of most solids in water increases, this is what I told you earlier. This is true for the solute that is in the form of solids. For most solids, the solubility increases with temperature. But for a gas, solubility will decrease with temperature. Have you ever seen, when you heat a liquid, bubbles coming up from the liquid? Now, what is those bubbles? When you heat water, the bubbles that come up are actually dissolved air escaping. When you heat water, the ability of water to hold dissolved gases decreases. That means dissolved gases will escape, and that is the bubbles you see. When water is heated, bubbles that rise are dissolved air molecules escaping from water. Now, another quantity that affects solubility of gases in liquids is pressure. By increasing the pressure, you can make more gases dissolve in a liquid. In fact, I told you earlier that when in the factories, when sodas are canned or bottled, they are canned or bottled in high pressure. Carbon dioxide is dissolved in soda at high pressure. If you increase the pressure, solubility will increase. But when you decrease the pressure, when you open the soda can, the dissolved gases will escape suddenly, creating that pop sound. So pressure has little effect on solubility of solids, but increased pressure will cause more gas to dissolve in liquids. Solubility of solids has very little effect. The pressure plays very little role in solubility of solids in liquids, but pressure plays a tremendous role in the solubility of gases in liquids. Soda cans contains large amount of gases dissolved at high pressure. When you open a soda can, gases come out of the solution, causing the pop sound. Now, solubility of gases decreases with temperature but increases with pressure. You must remember that. They are important concept that is important for our everyday life. Solubility of gases in liquids will decrease with temperature. As the temperature increases, solubility will decrease. And as pressure increases, solubility will increase. Now, the increase in solubility of gases with pressure is of great interest in scuba diving. Do any of you go for scuba diving? Well, if you go deeper and deeper into water, there will be a big column of air standing above you. That means the pressure will be very high. At increased pressure, more gases will dissolve. That means when you go deeper and deeper, more gases will dissolve in your bloodstream because of the increased pressure. Now, Air consists of mostly nitrogen and oxygen. About 1 liter of nitrogen is dissolved in our body fluids and cells. So, because air is made up mainly of nitrogen, our body fluids contains a lot of that gas. Our body fluids has lot of nitrogen dissolved in it, especially blood and other fluids in the cell. Now, it does not take part in exchange of substances and respiration like oxygen does. Nitrogen plays no role in exchanging materials like oxygen does. Oxygen plays a tremendous role in there. Now, while diving, the increased pressure causes more gases to dissolve in the body fluid. While surfacing, the pressure suddenly decreases, resulting in the release of dissolved gases by the cells and body fluids. And that can sometimes cause death if you are not careful. So if you are an experienced scuba diver, you know that you cannot suddenly surface. You need to give yourself time so that the dissolved gases will gradually come out and it will not cause harm to you. If the diver ascends too fast, gases begin to form bubbles that can plug small arteries and cause serious damage by stopping the blood flow to vital organs. Now, this formation of bubbles is called decompression sickness. Those who go for scuba diving know this process, decompression sickness. And most of the people who do scuba diving experience that decompression sickness. Now, the symptoms ranges from itchy skin and fatigue to serious mental problems as numbness, inability to speak, and even death. So, take care, those who go for scuba diving. Okay, let's now talk about another type of solution called electrolytes. What is an electrolyte? When an ionic substance like sodium chloride, you look at the way sodium chloride is written. Sodium chloride are aggregate arrangements of sodium ions and chlorine ions. And when sodium chloride dissolves in water, what happens? We talked about it. The hydration, the force of hydration results in these ions being pulled apart. So these ions get separated. That means a solution of sodium chloride contains these free ions. And you know that when anything that contains ions will become electrically conducting. When we talked about measuring radiation, we talked about that. We said ordinary air is not electrically conducting. But if you allow a beam of radiation to pass through ordinary air, this radiation can create ions along its path. Now, when ions are present in air, that air will conduct electricity. We can pass electricity through that air. In the same way, a solution that contains ions become electrically conducting. You can pass electricity through it. Such a solution will allow electric current to flow through it. Alright, what kind of a solution will allow electric current to flow through it? A solution that contains free ions. When NaCl dissolves in water, the ions Na positive and Cl negative get separated. So the solution now contains free ions. Ions are electrically charged particles. And as a result, such a solution will allow electric current to flow through it. Or we say it becomes electrically conducting. And such a solution is called an electrolyte. An electrolyte is an electrically conducting solution. You know that our body fluid is an electrolyte. It conducts electricity. Our body is a good conductor of electricity. That is why when you touch something live electrically, you get a shock. Why? Because electricity can pass through your body to the earth. Then you become a medium, and that is what gives you that electrical shock. Now, pure water, being a covalent compound, does not conduct electricity. But most tap water actually conducts electricity because it is not pure. You see, tap water contains small quantities of magnesium, calcium, and so on ions, and they conduct electricity. Sugar dissolved in water does not conduct electricity. Now, watch this. Salt dissolved in water will conduct electricity. Why? Because the ions get separated. Sugar is not made up of ions, and therefore when sugar dissolves in water, you have no free ions. Therefore, there will be no electricity. Now, I have some sulfuric acid here. If some sulfuric acid is put in water, the same process happens. You get ions getting separated, and now the solution has large number of ions, and that solution will conduct electricity. Now, solutions that do not conduct electricity are called non-electrolyte. So you must distinguish between electrolytes that conduct electricity and solutions that do not conduct electricity are called non-electrolytes. Now, pure hydrogen chloride, HCl, does not conduct electricity. Now, let me see if I can show you an electrolyte and how it works. Now, here I have a battery that can allow a current to flow through a conductor. I have connected the battery to an electrical meter, and I'm going to now connect it through water. Now here, if I can connect these two ends, now look at the meter, I will only connect it for a moment. If I just touch it, look at the meter now, oops, there was a large current flowing. Now, I'm going to put this in water. Now, if water allows electric current, then a current will flow. Now, can you see I have the water in here? I think you can see. I'm going to put these in water. Now, you can see there is a very small current. A very small current. Now, that is caused by the dissolved ions in water. Now, I can actually make it really a good conductor by putting some acid in it. Let me see if I can find some acid. Now, here I have some acid, and I'm going to put a very small quantity into it. There you are. Now, inside, now this is a solution. This is a solution of sulfuric acid in water. What has happened is the hydration has actually caused ions to separate, and there are hydrogen ions and other kinds of ions we will talk about in a moment. Now, when I put these in that solution now you can see that the current is much more. Well, not very much, because I've only put a small quantity. Now, this is now an electrolyte. An electrolyte allows electric current to pass through it. Okay, So you know what an electrolyte now is. When HCl is dissolved in water, the positive hydrogen atom is attracted by the negative oxygen atom. You know that water molecules are polar. Now, when HCl is dissolved in water, the hydrogen and chlorine ions are broken apart by the polar water molecules. That means free ions will now exist in there. The H plus stick to the water molecule, creating an H3O positive, and Cl negative stays free in the solution. Now, watch this one more time carefully. When HCl is a compound hydrochloric acid, that is one atom of hydrogen and one atom of chlorine. Now, when it dissolves in water, what happens? The positive hydrogen atom is attracted by the negative oxygen and water, breaking this into H plus and Cl negative ions. And now, this H plus ion will stick to a water molecule. It will stick to the negative end of the water molecule. See, a water molecule is H2O. When this H plus gets stuck to it, it becomes H3O with a positive charge. Actually, this ion is called a hydronium ion. So, when HCl dissolves in water, you have this hydronium ion, H3O plus, and negative chlorine ions. That means H2O plus HCl. When HCl is mixed with water, what gives in that reaction is H3O plus, that is hydronium ions plus chlorine ions. Now, this solution is an electrolyte and is called hydrochloric acid. So what you saw now is actually a solution of the acid that contained hydronium ions and other negative ions, and that is the reason why it allowed electric current to flow through. Now, H3O plus is called hydronium ion. Alright, try and learn this. H3O plus is a hydronium ion. Let's now talk about vapor pressure and boiling point. What is boiling point? Every liquid now turns itself into a vapor at a particular temperature. Well, actually, liquids turn into vapor at all temperatures. But massive conversion from liquid to vapor happens at a particular fixed temperature. And that temperature is what we call boiling point. Now, boiling point of a liquid depends on pressure. Let's talk about that. Evaporation is the process by which liquid molecules leave the liquid to become a gas or a vapor. Now, this occurs at all temperatures. Now, on a frigid, cold morning, if you look at the surface of a swimming pool or a lake or a river, you can see water vapor hanging above it. It means even at 0 degrees Celsius, water is evaporating to become vapor. So evaporation of a liquid to vapor happens at all temperatures. Now, a liquid enclosed in a container has its vapor on its surface. That means when I have a liquid, here I have a liquid enclosed in a beaker. Now, this liquid has its vapor on its surface. So the space where I'm pointing now contains large numbers of the vapor molecules of this liquid. And those vapor molecules are actually exerting a pressure on the liquid surface, and we call it vapor pressure. Okay. Now the pressure exerted by this vapor on the liquid surface is called vapor pressure. When you look up into the pool or into the lake, you see the vapor on the surface. That vapor is actually exerting a pressure on the liquid. When you put a pot of water to boil on a stove and close it, what happens? The amount of vapor on the surface of the liquid will increase, will keep on increasing with temperature. You know that when you open it, you see a lot of vapor coming out. So that means as you keep on heating, the amount of vapor will increase. As the amount of vapor increases, the pressure exerted by that vapor on the liquid surface will also increase. That means the vapor pressure will increase with temperature. Now, as vapor molecules accumulate above the surface of a liquid, they move randomly and sometimes return to the liquid. So, a vapor there always may not remain as vapor. These molecules of vapor will be randomly moving, and some of them, when they come and hit the liquid surface, will return to the liquid. Now, molecules of liquids leaving to become vapor and vapor returning to liquid continuously happens on a liquid surface, and it happens all the time at all temperatures. Now, which of these is faster? You see, molecules leave liquid body to become vapor. Also, the vapor molecules return to liquid. Now, sometimes both these rates are equal. That means the number of molecules going from liquid to vapor will be equal to the number of molecules returning to the liquid. That means the amount of vapor above the liquid surface will remain a constant. Now, when the number of molecules leaving the liquid surface is the same as the number of molecules returning to the liquid, the vapor is said to be in a state of equilibrium. In a state of equilibrium, and the space is now saturated with vapor. So a space that is saturated with vapor, what can you then call the pressure exerted by that vapor? The pressure exerted by that vapor on the liquid surface is then called the saturated vapor pressure. So here I have an illustration of molecules escaping the liquid to become vapor and some other molecules hitting the surface to return to the liquid. Now, when the number of molecules leaving the liquid to become vapor equal to the number that returns to become liquid, we have equilibrium. And the space above the liquid surface is now saturated with vapor. Now, that state of saturation can be changed by changing the temperature. Now, the pressure exerted by desaturated vapor on the liquid surface is called saturated vapor pressure, or abbreviation SVP. So what is the saturated vapor pressure of a liquid? When the vapor on the surface of a liquid is in equilibrium. In other words, the number of molecules leaving the liquid to become vapor equal to the number of molecules returning from vapor to liquid, we say there is equilibrium between the vapor and the liquid. That is, the space above is now saturated with vapor. You see, if the space is not saturated, then more molecules will leave the liquid than molecules returning it. When the space becomes saturated, it cannot accommodate any more vapor at that temperature. That means if some liquid molecules become vapor, that many now have to return to become liquid. So when this is in a state of equilibrium, you say the space above the liquid surface is saturated, and the pressure exerted by this vapor on the liquid surface is then called saturated vapor pressure. Now, here I have tried to show some illustration. This is liquid water. As the vapor begins to accumulate, that vapor will begin to apply a pressure on the liquid surface. And if the space is saturated, then the pressure exerted will be saturated vapor pressure. We can measure the pressure by using an arrangement like this. Now, this is mercury inside. If this tube here is open, then the pressure on this face will be the atmospheric pressure, the external pressure. And the pressure on this side will be the pressure due to the vapor. If the two levels are the same, it means the atmospheric pressure. Now, I want to open this tube. Only if the tube is open will the pressure here will be atmospheric pressure. So when the two levels are the same, the atmospheric pressure and the vapor pressure are both the same. If the vapor pressure is greater, you can see it will push down the mercury. The pressure here is now greater than the outside pressure. So as the evaporation increases, the pressure of the liquid also increases. You can see that there is more vapor here. Initially there is no vapor, there's no vapor pressure. As the vapor builds up, the vapor pressure increases. You can see it pushes the mercury down. The same way the vapor pushes the mercury down, it is also pushing on the liquid surface. And it is that we call the vapor pressure. And finally, when the space is saturated with vapor, now the pressure exerted is saturated vapor pressure. When there is no vapor, the pressure is the atmospheric pressure. Alright? As the vapor builds up, the vapor pressure increases. The pressure inside now is greater than the outside pressure. Now, the vapor is saturated. When the vapor is saturated, what you see here is a measure of the SVP, or saturated vapor pressure. Now, what happens when you increase the temperature? When you increase the temperature, a given space can contain more vapor. The ability of a space to contain vapor increases with temperature. That means at higher temperatures, more molecules will leave liquid, and therefore the SVP will increase. Now, this illustration shows that normal air, when the space is saturated, the number of molecules leaving the liquid will be equal to the number returning. But if you warm air, if you heat air, more molecules will leave liquid than the number that returns. But if you cool down air, more will return than the ones that go from liquid to vapor. That means SVP of a liquid increases with temperature. As the temperature increases, more liquid molecules will leave to become vapor. That means the number of vapor molecules on the liquid surface will increase. Therefore, the pressure exerted by them will also increase. As a result, the saturated vapor pressure of a liquid increases with temperature. When you heat a liquid, its saturated vapor pressure increases, and when the SVP exactly equal to the atmospheric pressure. Now, this is when the liquid begins to boil. So when does the liquid begins to boil? As you heat a liquid, the vapor will begin to build up on the surface. And as the temperature increases, the vapor pressure will increase. A time will come when the saturated vapor pressure on the liquid surface is exactly equal to the outside external atmospheric pressure. It is at that temperature that the liquid begins to boil. That means at that temperature, the liquid not only becomes a vapor at the surface, but it becomes a vapor throughout its body. That's the reason why the liquid sort of violently moves about. Now, there is a wholesale conversion of liquid molecules to vapor molecules. So here, I have shown a diagram of the temperature against external pressure. As you increase the temperature, the SVP keeps on increasing. At a particular temperature, look at for water. For water at 100 degrees Celsius, the saturated vapor pressure will be exactly equal to 1 atmospheric pressure. That means saturated vapor pressure equal to the atmospheric pressure, and that is when the water boils. Well, can you tell me, then is there any way we can make water boil at a higher temperature? Is there any way we can delay the boiling of water? Water does not boil at 100 degrees. I want the water to boil at a higher temperature. What should I do? Well, all I need to do is to increase the pressure. Now, if you increase the pressure to 2 times the atmospheric pressure, look at this. At 2 times the atmospheric pressure, water will boil about 130 degrees where I'm holding. Am I right to say that? So, at about 2 times the atmospheric pressure, water boils only around 130 degrees. If the pressure is 3 times the atmosphere, it will boil around 140 degrees. And at 5 times the atmospheric pressure, water boils only at 150 degrees. Now, how many of you have used a pressure cooker? What is a pressure cooker? A pressure cooker does not allow vapor to escape. The vapor that is formed inside is allowed to stay inside to build pressure. Now, as the pressure increases, water will boil at a higher temperature. So when you cook in a pressure cooker, suppose your pressure cooker can increase pressure inside to about 3 atmospheres. If your pressure cooker can build up pressure inside to about 3 times the atmospheric pressure, then water inside your cooker will be boiling around 140 degrees Celsius. You see, if your food is cooking at 140 degrees Celsius, it will cook a lot faster. So a pressure cooker can be used for fast cooking. Alright, if you haven't used one, try one next time. If you normally take 1 hour to cook meat, in a pressure cooker, you can do it under 20 minutes. But the quality of cooking will also be high. This also means that if you reduce pressure, what happens if you reduce pressure? you can make water boil at a low temperature. Look at this. At half the atmospheric pressure, water will boil around 50 degrees Celsius. So, if you go higher up, you know that if you go on a mountain top, the pressure there will be low. Now, if you go to Mount Everest, the pressure on Mount Everest is only about 25% of the pressure at sea level. So, if you go to Mount Everest, you can boil your water at around 25 degrees Celsius. That means you will not be able to cook an egg there. Can you cook an egg at 25 degrees Celsius? No. So if you ever plan to go to Mount Everest or climb any big mountains and want to cook there, carry a pressure cooker with you. Alright. Now this process is called boiling. What is the process called boiling? Boiling happens under what conditions? Boiling happens when the saturated vapor pressure is equal to the external pressure. That is when boiling takes place. Boiling point of a liquid is the temperature at which its saturated vapor pressure is equal to the external atmospheric pressure. For pure water, this happens at 100 degrees Celsius. When the saturated vapor pressure of water equal to 1 atmospheric pressure, water will boil at 100 degrees Celsius. So we say the boiling point of water is 100 degrees Celsius. Now, what happens to the boiling point of water when a solute is dissolved in it? What do you think? If salt is dissolved in water, what will happen to its boiling point? Well, the molecules of solute at the surface will make it difficult for molecules of water to escape, become vapor. You see, when a solute is dissolved in water, there will be the molecules of those solute present at the surface, which will make it difficult for water molecules to escape to become vapor. That means you need to heat that water to a higher temperature in order to boil it. So when salt is dissolved in water, it will increase its boiling point. So as a result, the vapor pressure above the surface of the solution will be less than the vapor pressure on pure water at the same temperature. Means you need to now increase the temperature. In order that the vapor pressure may be equal to the external pressure, the temperature needs to be above 100 degrees Celsius. So if salt is dissolved in water, that water will boil above 100 degrees Celsius. I have seen many people cooking rice. When they cook rice, they put a little salt in it. Now, some people say they do that to cook faster. Is that so? Well, if this physics is right, then the answer is right. If salt is added to water, it increases the boiling point. That means the rice will be cooking at a higher temperature. But actually that increase in temperature is not very high. I think most often people add salt when they cook rice to improve the flavor of rice. But of course the argument that it improves the cooking time or it can be cooked faster is also right, because salt water boils at a slightly higher temperature. For every 1 mole of a substance dissolved in 1000 grams of water, the boiling point is increased by 0.5 to 1 degree Celsius. Not much of an increase. So salt added to water will increase its boiling point. Adding salt while cooking will increase the boiling point, and so cooking can be done at a higher temperature and therefore more efficiently. Boiling point of a liquid can also be increased by increasing the external pressure. That's what I was talking to you about, the pressure cooker. When external pressure is increased, in order that the vapor pressure may be equal to the external pressure, the liquid needs to be heated to a higher temperature. You see, in order that when the vapor pressure is high, when the vapor pressure is 2 times the atmospheric pressure, well, at that pressure water boils, say, at around 120 degrees Celsius. There you are. At twice the atmospheric pressure, water boils around 120 degrees Celsius. In a pressure cooker, food is cooked at a higher pressure and therefore at a higher temperature, and therefore it is faster and more efficient. What is freezing point? So far we were talking about boiling point. In the same way, every substance has a freezing point. A liquid freezes to become a solid. When the kinetic energy of the molecules of a liquid is sufficiently low, the molecules come together to form the crystal structure of the solid, and this is the process of freezing. As you decrease the temperature, the molecules slow down, and finally they will come and arrange themselves, forming the crystal structure of the solid. This is what happens when you lower the temperature of water. Finally, water becomes ice. Pure water freezes at 0 degrees Celsius under normal atmospheric pressure. When a substance is dissolved in water, the presence of solute particles in solution interferes with the formation of the crystal structure. You see, when you have a solute dissolved in water, the presence of those molecules will interfere with the formation of the crystal structure. That means it will delay the freezing process. So what happens? When a solute is dissolved in water, that will make the freezing point lower. The temperature needs to be reduced to below the normal freezing point for freezing to occur under these conditions. Therefore, a solution freezes at a lower temperature than pure solvent. So salt water will remain water even below 0 degrees Celsius. Now tell me, why is salt spread on road when it is icy? Because when salt is spread, the ice will melt to become water, because water will not become ice at 0 degrees Celsius when salt is dissolved in it. The presence of salt will lower the freezing point. Seawater freezes at a temperature lower than 0 degrees Celsius. When ice begins to form, the salinity of water increases, depressing the freezing point. Thus, seawater does not have a fixed freezing point, but has a lower and lower freezing point, because as more and more water freezes, the salinity of water keeps on increasing. All right.